these are the solutions to the last 10 pages of the free response problems, the green pages in your review packet. So the very first one on page 21, is your food safe? It wants you to explain if the sources of error are included in the margin of error. To answer this, you will want to use page 607, specifically this top part. So this is right here is specifically talking about what does margin of error explain. So it gives you 3 scenarios and it just wants you to say, yes, it'll account for this, or no, it won't. So for the landline, this is under coverage, so it's not included. The margin of error does not account for under coverage. For the people that didn't answer the phone, that's not included because the margin of error does not account for non-response. And then lastly, for the chance variation in the random selection, included. Margin of error is calculated to account for sampling variability. So the margin of error is there because we know samples will be different. We're using one sample to estimate a value for the population, but we know that that sample value, it would be or is different than a different sample value. So the margin of error is calculated to say, hey, our sample value was 67%, but we could be off by about 3% on either end. So we're pretty confident that it's between 64% and 70%. That's what margin of error does. Margin of error is saying, we know that this is just one sample value, so we could be off by about this much. Okay, page 22. Give or state the issue with the statement. So the margin of error is said to be valid at the 95% confidence level. This means that if the same questions were repeated in 20 polls, the results of at least 19 surveys would be within 3 percentage points of the results for this survey. So you can see that I have some things highlighted in this statement. Those are what is wrong. So see if you, given the hint that I have with the highlighting, see if you can figure out what the issue is. Okay, so I just rewrote the statement with what they should have written. So if the same questions were repeated in 20 polls, the results of about 19, not at least 19, about 19 surveys would be within 3 percentage points of the true proportion. So this is what I was just talking about on the previous problem. We know that every sample will be different. So when we get our one sample value, we use margin of error to say this is our estimate for the population, but we could be off by about 3%. Be off from what? From the true value. So this is our estimate of the true value, but we could be off by about 3% from the actual true value. Okay, construct a 95% interval for the proportion of all adults who use the internet. This is very straightforward. Remember to check your conditions. So go to your confidence intervals unit. So bright green tab, go to the construct confidence intervals for P. So that's page 612. And do everything that you see on this page. B, I would only do part B considering after you consider where you're at. So if you're watching this solutions video on Saturday night and your exam's in 2 days, don't do part B. Like you need to be studying, not finishing these problems, so you're behind. So I would not spend any time on part B. If you are feeling pretty comfortable with the content, you're feeling pretty comfortable with the review, you've done well all year, you're going to want to look at the solutions for Part B. So, A, everybody should do. B, you need to use your own judgment on whether or not you should be doing Part B. Okay, so I'm just going to uncover, and I'm not really going to go through this in depth. I just want to say that one, for full credit for E, you have to have what I have written in red. You have to name correctly the procedure that you're doing. You check your conditions: random digit dialing, large counts, 10%. You calculate your confidence interval and then you make a statement. We are 95% confident that the interval from 60.9% to 65.1% captures the true population proportion of all adults who use the internet. Okay, if you are feeling confident with the material, you should try Part B. And there are a handful of you that should be doing Part B, like Brooke, Lizbeth, Daniel, Hannah. Several of you. Those aren't the only ones. But Carter, Mia. So maybe a lot of you should look at Part B. So Part B is new, but you've seen things similar. So first thing that we want to do is define the variables that we're going to use. This is a 2-sample Z interval. One sample is users, one sample is non-users. So P sub U is the true proportion of adult internet users who expect businesses to have websites. And P sub N is the proportion of adult non-internet users who expect businesses to have websites. So first of all, this is a 2-sample Z interval. These are the 2 samples that we're looking at: the proportion or the sample of users, the sample of non-users. We want to estimate the difference between the 2 samples with 95% confidence. Well, here's what that interval looks like. It looks like all the other intervals we've ever done. The point estimate plus or minus the critical value times the standard error. Okay, so here's where things get different. Your Z critical is the same. Your point estimate, though, is very simple. If you're trying to estimate the difference between the two, then the point estimate is the difference between the two. Z critical is the one that we always use. Standard error now is this crazy formula. How do I know that? Well, it's in my formula sheet that they will give you. So difference of sample proportions, boom, right here. So using that information, I would encourage you to finish this problem. So pause and really finish. Okay, hopefully you really tried. So here's the work associated. The interpretation is we are 95% confident that the interval from 0.369 to 0.451 captures the true difference in the proportion of internet users and non-internet users who expect businesses to have a website. I know that this is another thing to add on right before your test, but some of you should add it on. I know that you can do it. I know that you've kept up with the work all year. If this is something that you can fold in to your toolbox, then you'll be better off. You won't pass or fail based on knowing whether or not to do this. But if you're really hoping to pass and you're maybe trying to get a 4 or a 5, you're going to want to stretch yourself and try to be able to do this on the exam. Okay, so for this problem, there is a question in the very first part of the prompt. So we're now on page 24. there's a question right at the end of this first paragraph. Explain why it would not be appropriate to use these data to construct a 95% confidence interval for the proportion of all U.S. adults who have tattoos. Try to answer that. Why can we not use these to construct a confidence interval for all U.S. adults? Okay, so this data only represents adults who have agreed to participate in Harris Interactive surveys, not all U.S. adults. Because the chances are adults who agreed to participate may differ in some way from the population of U.S. adults that affects the results of the survey. This is good enough. These two together is best. Okay, so then they tell us 98 teachers responded. They got a proportion of 23.5%. Construct a 95% confidence interval. So that's exactly like the last problem. Does the interval provide convincing evidence that the proportion of teachers at the Institute is not 0.14 as it was in the Harris poll? And then 2 of the teachers refused to respond to the survey. Could your answers have changed if they had responded? Okay, so A you did in the last problem. B is 14 in your interval. Is 0.14 in your interval? If 0.14 is in your interval, you do not have convincing evidence it's different. If 0.14 is not in your interval, you have convincing evidence that it's different. This one, you actually have to think about, well, what would have happened if both the teachers that we add in say yes? What would have happened if they both said no? What would have happened if one said yes and one said no? You really want to think about, well, what would have changed if 2 said yes or 2 said no or one of each? Okay, so for part A, this is your confidence interval. Notice 1 sample Z interval for P. I am not going to walk through this entire problem. Please make sure that you checked your conditions. B. Yes, the interval gives convincing evidence that the proportion of teachers at the Institute with tattoos is not 0.14 because it is not included in the interval. So because it's not in this interval, that means 0.14 is not a plausible value. So we have convincing evidence that the proportion of teachers is not 0.14. And then C, I actually just used my calculator to adjust the values up here, and I figured out what the confidence intervals would be. So if both of them said yes, the interval would change to 0.16 and 0.33. So if both said yes, these both would increase. If both said no, then it drops down to 148 and 312. If one said yes and one said no, it was in the middle of these two, so I didn't write it down. If both said yes, the interval values increase. If both say no, they decrease by a little. And if one says yes and one says no, the confidence interval is between. So the answer to part B would not have changed if we got responses from the 2 non-responders, because 14 is not in either of those. So this is enough to earn me essentially correct. I'm explicitly saying if both of them said yes, this is what would happen. If both of them said no, this is what would happen. The AP graders know it's implied that 1 yes, 1 no would be in the middle. So the answer to part B would not have changed. And I probably should have written here because 14 is not in either interval. I do think that this is enough though. Just giving the confidence interval, I do think it's enough to give me full credit for saying our answer would not have changed. this page? Is this page out of order? Well, that's page 27. Where's page 26, family? Okay, page 26. Do the data provide evidence of a difference in the average time required to perform two tasks? Include graph and numerical summaries. Okay, so do the data provide evidence of a difference in the average time required? I believe that I found the difference. So for this one, for each subject, I found the difference between the two, and then I made a box plot. You could make a histogram, you could make a dot plot. So they want to know, is there a difference? We'll actually find out if there is a difference. So this is similar to the paired t-test. Is similar. Don't do the exact same thing, family. It's just similar. Page 724. So you want to make a third row or column of the actual differences. Then make a graph of those differences. So make a histogram, a dot plot, a box plot. Okay, then for 9.3, explain why it is not safe to use T procedures to do inference. So check conditions. I bet you on this one we need to check the conditions. So like, did we take 10%? Was it a random sample? Did we have large counts? Check those. I don't really know why this is out of order, but here are my solutions. So here's my difference. Notice on my graph, I've scaled and labeled. I've given the direction of my subtraction. As shown on the box plot above, the median difference is 6 and the minimum is 0. For all students, the time it took to identify the color was the same or longer than the time needed to read the words. Typically, the students who are able to read the words in about 6 seconds, typically the students were able to read the words in about 6 seconds less time than it took for them to identify the color. Make sure that you have this outlier if you did a box plot. Make sure that you have that outlier because that would cost you points. Then the next part, it is not safe to use a paired T procedure because n is equal to 16, which is less than 30, and the box plot has an outlier. So the normal condition is not met. Okay. What is next? Can we use a student's word task time to predict his or her color task time? Make an appropriate scatter plot to help answer this question. So that's this. This is your data. So make a scatter plot of, I think I went in order, words as the X and Y as the colors. Use your calculator to find the least squares regression line. That's easy. Find the residual. That's easy. And explain a p-value. Okay, so here is my scatter plot in terms of word on the X and Y, color time on the Y. This scatter plot looks horrible. So I had to graph it. My data was in list 5 and 6, so I hit blue button, Y equals. I do the scatter plot. I change my list to 5 and 6. I graph. I see nothing, so I hit zoom, 9. And now this scatter plot looks way better than my scatter plot. this is definitely weak association. So there is a weak positive linear association between word task time and color task time. In general, as word task time increases, so does color task time. B, find the least squares regression line. C, find and interpret the residual. D, the p-value is saying if the null is true, there is a p-value chance that we would get the results that we got. So, if the true slope of the line relating word task time to color task time is 0, meaning there's no relationship. So, I should go back to this one. Assume that the conditions for performing an inference about the slope of the true regression line are met. So what this is saying is slope is 0, which means there's no relationship, no linear relationship between the two variables. HA, slope is bigger than 0. There's a positive linear relationship. What does that mean? What does a p-value of 0.0215 mean? So if the null is true, well, the null is that there's no relationship, so slope is 0. There is a 2.15% chance that we would get a slope value of 1.321 just by chance. So if the slope of the line is really 0, there is a 0.0215 probability that the experiment would result in data that produces a slope of 1.1321 or larger by chance alone. You can see in some of these problems that we've done a confidence interval relating to slope. Now you're seeing a test related to slope. You just have to use your knowledge of those things, of confidence intervals and tests, to work your way through those problems, and you'll be okay. So make sure that you truly understand this, that the test shows, well, depending on our significance level, the test shows that there is a positive linear relationship. Okay, we're getting there, fam. Page 29. You can skip C and D. So first, Marcella, it has a normal distribution. Find the probability that the shower lasts between 3 and 6 minutes. So that is this situation on your standard normal. You're finding the space between 3 and 6 minutes, or the area between 3 and 6. And then if Marcella took a 7-minute shower, would it be classified as an outlier by the 1.5 times IQR rule? This is them giving you an area and you finding the z-score. So if her mean is 4.5, this would be a high outlier. So you need to find the upper bound. How will you find the upper bound? You need to find the z with a of 75% to the left, because that's the third quartile. Okay, for part A, I'm not really going to go through it. Just make sure that your normal curve is named. Your flags are clearly labeled. Your area is shaded in. I'm clearly showing the z for the lower bound. I'm showing the z for the upper bound. I'm giving a statement of what I'm finding, and I found the percent. I should say a mathematical statement. Here is my conclusion. There is a 0.905 probability that Marcella's shower lasts between 3 and 6 minutes on a randomly selected day. Okay, for B, I found both. You have to find both to know IQR. I apologize. So you had to find quartile 3. This is my equation. Quartile 3 would have 75% of the data to the left. You had to find quartile 1. Quartile 1 has a Z with 25% of data to the left. So notice I have it labeled. Z-score of 0.67 matches an area to the left of 75. Z-score of negative 0.67 has an area of 0.25 to the left. So my upper bound is my quartile 3 plus 1.5 times my IQR, which gives me an upper bound of 6.777. Yes, 7 is greater than my upper bound, so a shower time of 7 minutes would be considered an outlier. Is this our last one? Hallelujah. Okay, 1. How well does one twin's IQ predict the other? Give appropriate evidence. So you're going to want to make a scatter plot and find your R or your R squared. Do identical twins living in low-income homes tend to have lower IQs? Give appropriate evidence. For part B, I would do something similar to this problem. You don't have to make a box plot because it's not saying give graphical evidence, but in the very least, I would find the difference in IQ to answer that question. Okay, so my scatter plot turned out pretty good. I checked it against the calculator scatter plot. There is a strong positive linear association between the IQ of twin A and the IQ of twin B. The correlation is 0.91, so the IQ of one twin will do a good job of predicting the IQ of the other twin. 0.91 is a very strong relationship. So I think it'll do a good job. Remember, 1 is a perfect relationship. So 0.9 is very close to that. Then for B, I found the difference between twin B minus twin A. So twin B had the high income home. So if there truly is a difference, these numbers will be positive, and you can see that they are. Family, I just had a Mayday situation. Those are my pugs. I apologize. I'm unprepared. My binder hit the power button on my computer and completely shut it down, and then I had a panic attack because I thought maybe I lost the entire video that I just filmed. So this is the ending of that question. All but one difference in IQ is positive. This suggests that the twin living in the high-income home tends to have a higher IQ than the one living in the low-income home. So that's it on our free response sections. I'm going to go through the multiple choice, but because I have given you quizzes in Canvas to check your answers, I probably am not going to go through those too in depth. If anything is unclear, please make sure that you ask questions to get them cleared up. If you are watching these solutions videos Sunday night before your exam. I would focus on the things you feel good about and let go of the questions that you have. The last couple of days before the exam, you don't want to be trying to learn new things. You want to be studying and going through the things that you know. So up until like Friday, Saturday, email me, come see me, ask any questions that you have. I'm super happy to help you. But once it gets closer to the test, if you have a lot of lingering questions, you should probably just focus on the things that you know and make sure that you strengthen your memorization of those things. Okay, so that's it. Love you. If you made it through all those problems, I'm super proud of you. If you made it through all those problems before your exam, you're the real MVP. Love you guys.